All right, so we're talking about exponents and logarithms. So transitioning to just straight exponential expressions here, talking about logarithms. Specifically, these two questions, or two items here: how to convert between exponential form and logarithmic form of an equation, and then what is e? What is this lowercase e business all about? So here we go. If you recall, your standard exponential equation here, 4 squared equals question. So what this means, or what this whole equation is asking, is essentially this question: what is the number that you get when 4 is raised to the second power, or when you get 4 times 4? That's what this is asking. This is saying, take 4 to the second power, 4 times 4, what number do you get? Obviously, the answer is 16. Now, what we can do is we can kind of rearrange those terms, rearrange, this right here, which is called the base, this the exponent, the power there, and we can write this thing right over here. Log base 4 of 16 equals what? And so this thing right here is asking, what is the exponent that I need to raise 4 to in order to get 16? So it's sort of like saying, if you have the base 4, what's the exponent that I need? So logarithms sort of follow this mantra: show me the exponent, or what is the exponent? A logarithmic term over here is essentially asking the question, what's the exponent that I would have to put raise that power to, or raise that base to, in order to get this power over here. Obviously the answer is 2, since 4 squared, 4 to the 2 is 16. Students, sometimes if they make a mistake anywhere, they tend to think, oh, this is the base, and this number right up here to the top right of it is the exponent. That is not the case. That's true over here. This is the base, and that's the exponent. But in a logarithmic equation, this number right here, which is a little bit up and to the right here of that base, that's the power. The exponent is over here on the other side of the equation, over on the other side of the equal sign. Okay, there's the base, there's the exponent, and 16 is the power. There's the same terms as we have over here. This is the base, this is the exponent, and that's the power, but they're just located in different positions. It shouldn't be that complicated. So this is what we call an exponential function, and this over here is, an exponential form, or an exponential equation, and then over here we have a logarithmic form, or logarithmic equation. So we could say that 4 squared equals 16 converts to log base 4 of 16, which equals 2. So just generically speaking, if we have b to the x equals a, then we could write that as log base b of a equals x. This is definitely something worth writing down right here. Something to note, when we don't have the base right there, like if this just says log 7, it's like, okay, well, log of what? Well, it kind of depends on the context, kind of depends on where you are. Different groups of people will write this, without the base, and they will have some assumptions. So traditionally in math books and on your calculator, if it just shows log, then it means log base 10. So that's why I said in the calculator. If you are on the Wolfram Alpha website and you just type in log 7, then it is going to assume that you mean log base e of 7. You're like, well, what is e? Well, we'll get to that here in a second. In fact, they actually kind of updated their website a little bit to let you know that this is the case. But anyway, that's not good of them. It also could mean log base 2 of 7 if you are in a computer science type situation. Talking about logarithms, because in computer science you pretty much just care about base 2 for all kinds of really awesome reasons. But anyway, for the most part, since I'm talking about this in a math context, and I just write log, I'm going to mean log base 10. So yeah, go figure. All right. Here's some sample questions you might see, you know, in homework or whatever. Something says, rewrite this in the other form. So if it's exponential, write in logarithmic form. If it's logarithmic form, write in exponential form. So here we go. Log base 2 of 32 is equal to 5. So there's the base. So I'll write that in the base position. This is the power. So I'll write it there in the power position, or the exponent rather. That's the exponent. And then here's the power, 32. And I'll write it over there. So 2 to the 5th equals 32. Ta-da! There you go. I've just rewritten this logarithmic equation as an exponential equation. All right. 7 to the negative 2 equals 1 over 49, which clearly that's true because that negative means you could put in the denominator and then square it, so that'd be 1 over 49. To rewrite that in log form, there's our base, so we say log base 7. And then the power, we put right here, 1 over 49 equals, and then ding, negative 2 for your exponent. So not too difficult there. We could rewrite this logarithmic equation, log base 8 of 1 over 64 equals negative 2. So here we go. There's the base, so there's the 8. Negative 2 is our exponent, and then equals the power, 1 over 64. Hooray! Converting is great. 3 to 0 equals 1. What does that mean? Well, log base 3, that's the base, what's of 1, that's the power, is equal to 0. So leads us to some interesting properties of the logarithm of 1. Alright, so what was that e thing all about? What is e? Answer, the natural number. It's also known as Euler's number. Yes, I said that correct. E-U-L-E-R. Euler's, named after Leonard Euler. He's actually got a lot of numbers, a lot of theorems, a lot of things. Oh, sorry about that. It's approximately 2.71828, and then on and on. There is a lot of stuff about E. There's actually, I think, 4 or 5 different ways that you can derive it, that you can figure out that it's that 2.718 number. There are lots of applications, and not just in math, and so not just in, you know, calculus and things like that, but in science, engineering. There you go. So E is a number. It's a constant. It's an actual number. Now, it's as far as we know, it doesn't repeat and it doesn't end. So it's a lot like pi, but it's a number. So if you were to see e to the third, that means 2.718, so on and so forth, but we'll just round it there to those 3 digits after the decimal. 2.718 to the third. If we would see e to the fifth, then that would mean 2.718, so on and so forth, to the fifth. Pi, e, 1, 0, I guess maybe you could throw in negative 1. I, that's the one I'm missing. There is the missing piece of that. Sorry, didn't write that fifth magic, amazing number there. These are amazing concepts in math. Whole books have been written on each one of them, actually. Well, okay, I don't know if there's been numbers written, a book written on 1, but 0, pi, e, and I, absolutely. So, whoops, getting behind here. Let's see. So log base e of 5, we can write that as ln of 5. So this is the natural log of 5, and I'm going to always kind of do the little cursive L thing. So log base e of 7, we would normally write that as natural log of 7. So if we have e to the 8 equals y, and we want to kind of go like we did a few minutes ago and rewrite this exponential equation as a logarithm, we would write log base e of y equals 8, which then immediately we would erase and write it as natural log of y equals 8. If I had ln x equals 4, we could rewrite that as, we kind of understand, all math students know that there's a hidden e right there. So e is our base, and then to the 4th, that's the exponent, equals x. Nice. Alright, let's do some evaluation here. So kind of moving away from that natural number there, e, for a few minutes. Let's just solve some basic logarithmic equations here. So we had log base 4 of 64 equals box. So the way I think about these is I normally like to convert them back to exponential form, since that's kind of the way my mind thinks naturally. And so what this is asking is 4 to the box, so 4 to some exponent equals 64. So what is that? 4 to the first is 4, 4 squared is 16, 4 cubed is 64. Up, 4 cubed, there it is, 3 is the number. So log base 64, or log base 4 of 64 is equal to 3. Log, and then of 1 over 10. If you are using the ALEC system, then that means log base 10. So log base 10 of 1/10 equals box. So let's convert that. So that means base is my 10, and then to the box exponent equals 1 over 10. So what number can I put right there? -1, because that'll flip it. Make the and put the 10 in the denominator. Great. So looking backwards, we talked about e, we talked about converting base to exponent form. What are these things? What is how to convert between exponential and logarithmic, and what is e, as well as just some basic logarithmic type equations there. Hope you enjoyed. Thanks for watching.